Hello, this is Mrs. Taylor, and I'm going to walk you through how to evaluate limits analytically. And in this class, analytically is synonymous with algebraically. So we're going to backtrack a little bit and look at some of those basic limits I introduced in the properties of limits video, because they're the premise of evaluating any limit algebraically. So with the exception of this first case, where if you have a constant, the limit equals the constant, in the second and the third case, the main idea is that you evaluate through substitution. So if you have some variable as part of your function, what you do to evaluate is you just take what x is approaching and substitute it in. So in this case, we have the limit as x approaches c of x equals c. It's just direct substitution. So if I'm given a problem like this one, where it says find the limit of the limit as x approaches 2 of negative x squared plus x minus 2, then I know that I can evaluate through direct substitution based on those limits we just saw. And because of the properties, I can find the limit of each of these terms separately and then combine it all together. And so from the previous slide, we know that I just take the 2 and substitute it in for x here and here, and then just use basic operations to find my limit. With direct substitution, my limit would equal this. I forgot my negative sign there. So it would equal negative 2 squared plus 2 minus 2. And when I evaluate that, my answer would be negative 4. So the limit as x approaches 2 of this function is negative 4. And I didn't have to use a graph or a table. And this is the definite limit as opposed to an estimate because I used algebra instead of a graph or table to find it. The thing to keep in mind is direct substitution only works for polynomials and rational functions with non-zero denominators. So in this case, I have the limit as x approaches 1 of x squared plus x plus 2 all divided by x plus 1. And because if I use direct substitution where I plug 1 in for x, because this denominator equals 2 and not 0, I can use direct substitution. If it was the limit as x approaches negative 1, I would not be able to use direct substitution. And we will get into methods for those cases next week. So for now, I can just use direct substitution to find this limit. When I substitute 1 in for x, it would look like this. 1 squared plus 1 plus 2, all divided by 1 plus 1. And then when I evaluate and simplify, my final answer would be 4 divided by 2, which reduces to just 2. And so that would be how I would evaluate this limit algebraically. Another property to keep in mind, and I believe I might have showed you this in the properties video, is with radicals. It works the same way. If you really think about it, a root is basically an exponent just in fraction form. So it works exactly the same as what we were just doing. You just use direct substitution. So the limit as x approaches c of the nth root of x would just equal the nth root of c. And as seen in the properties video, trig functions work the same way. You would just do direct substitution. And so this would equal tangent of 0, this would equal pi times cosine of pi, and c would equal sine squared of 0. And of course, you would have to know what those trig values are. You would have to have them memorized as well. So that is how you evaluate limits algebraically. And next week we will delve into those cases where you cannot use direct substitution. But for now, these are pretty straightforward.